In this module of Ember training, we're going to discuss some basic ZigBee concepts, including application profiles, clusters, and endpoints. Before viewing this module of training, it may be useful for you to go back and review the ZigBee architecture slides in the previous training curriculum, which discuss where the application profiles sit in the general architecture of a ZigBee design. So what are application profiles? In ZigBee, an application profile is basically like a miniature protocol on top of a ZigBee stack that defines application-level features. So things like lighting network's behavior or an HVAC network's behavior, real-life sort of use cases on top of the networking technology that talk about the kinds of applications we're going to be running here. So there's a 16-bit device ID within the profile that helps break down all of the things that that profile can do into different groups of functionality. And those groups of functionality are these devices. Those devices are subdivided further into what we call clusters. We'll talk about clusters more in just a minute. But envision that you have some kind of application profile. Suppose it's home automation, and home automation says there are a number of devices that can be in a home automation network. And each of these devices is effectively given its own unique ID. Now, those devices each have their own capabilities as far as what they can do and what kind of properties they have, what kind of messages they send and receive, and that's really what the profile is defining, is the behavior of those different device specifications. Now, if you need to build a custom profile because there's not a public profile that does what you want, you're certainly welcome to do that, but you should go to the ZigBee Alliance and request your own private profile ID so that over the air you can identify yourself as being some proprietary profile that's unique to you and not conflicting with someone else. And that way, when your messages go over the air, they contain this 16-bit profile identifier that distinguishes your messages on your profile from another message on another profile. So again, examples of these profiles would be HA, CBA, Smart Energy, or anything manufacturer-specific, an MSP, manufacturer-specific profile. So talking about the clusters in a bit more detail, within each device definition of the profile are a set of clusters that go with those devices. Now, a cluster is a group of related message types in a certain area of functionality. So there's a metering cluster, there's a ballast control lighting cluster, there's a color control cluster for color controlling devices, a temperature sensing cluster, that sort of thing. So each of these clusters is also, again, enumerated, this time by a 16-bit ID. So you can see the pattern of division here in terms of enumerating the different areas. And the clusters are generally defined in a kind of dictionary-like reference called the ZigBee Cluster Library, or ZCL. The ZCL defines a large set of clusters that can be used in any public profiles. So regardless of whether it's home automation or smart energy, if there's overlap between those two profiles, you can define the same set of functionality and just stick it into different profiles by inheriting it from the same library, and that's the ZCL, or ZigBee Cluster Library. Now, each cluster has a set of attributes, which are the properties that are maintained on the device that is responsible for those things, and a set of commands, which are the sorts of things that it sends and receives. The ZigBee Cluster Library also groups these clusters by what it calls functional domains. So clusters that are related, like color control and ballast control and lighting, that sort of thing, might go into a lighting functional domain, and things like humidity and pressure sensing and valve control might go into an HVAC, ventilation, air conditioning kind of functional domain. So in each cluster, we talk about a client and a server. The client is generally the one sending the messages to the server because the server is the device that actually has a set of attributes. So if we think about a lighting cluster, the actual lighting device that has the light on it would be the server, because that's the device that maintains lighting properties. And the devices that manipulate the light would be the clients, because they're trying to access functionality available on that light. So we have a client and we have a server, and the server maintains the attributes. The ZCL also stresses a standardized messaging format for commands, which ensures a level of interoperability, and that means that a designer doesn't have to come up with their own ways to say, turn this light to 50% brightness, because there's already a level control cluster that says, please adjust the level, and then there's a standard parameter in that command that defines the level. So if you're interested in the ZigBee cluster library, I encourage you to go to the zigbee.org website, and you can download the ZigBee cluster library for free. So just to depict this graphically here, we have a set of clusters which are grouped into functional domains. The collection of all clusters in all domains is the ZigBee cluster library, and then you mix and match clusters from different domains into application profiles to suit the needs of devices within that profile. In other words, a simple thing like on-off, that kind of cluster could exist across different profiles, and so you might see that same cluster appear in different application profiles. So how do we associate different application profiles with a device? The answer is we have these things called endpoints. The endpoints are service points on a node. There can be, in theory, up to 255 of these defined. However, there's also an endpoint 0, which is built in by the stack, and endpoints 240 through 255 are reserved for special future functions. So that effectively leads 240 endpoints that the user could implement here. Endpoint 0 currently is reserved for network configuration and administration, and is generally used by the stack for gaining information about other devices. But applications could use endpoint 0 to learn about devices themselves. Endpoint 255 is used as a generic broadcast endpoint. So if you want to send a message and you're not sure which endpoint to send it to, endpoint 255 could be used to distribute it to all endpoints on a destination. So to put this in perspective, each endpoint is implementing a single device type from a single application profile. So in theory, as an example, we could have endpoint 0 occupying the built-in ZDO, ZigBee device object from the ZigBee device profile, which is all of the internal stack-defined support. We could have an endpoint 1, which is a thermostat from the home automation profile. Endpoint 2 might be an on-off output from the home automation profile. And then endpoint 3 might be some kind of in-premise display from the smart energy profile. And endpoint 4 might be some kind of manufacturing-specific profile implementation for any vendor-specific extensions. So by addressing a different endpoint on a single node, a single radio, this allows us to access different areas of functionality depending on what we want to use. So each of these endpoints would have support for parsing different clusters. Okay? So it's basically a subset of your node that handles certain areas of features. And so different endpoints can come from different profiles to the extent that those profiles can coexist on the same device. It may be that security constraints or code size constraints might not make that possible, but in theory, there's nothing that stops a device from using multiple application profiles on the same node. However, because these endpoint numbers are not standardized other than the reserved endpoints, it means that there's some amount of service discovery that has to happen here. So typically, when a node enters a network, it needs to query devices to find out what endpoints they have and what services are implemented on those endpoints. So each endpoint, when you query it, comes back with a descriptor and a cluster list. The cluster list is the list of client clusters and server clusters supported on that device. And the descriptor is information about which profile that endpoint is implementing, which device within that profile is being implemented, and then how many inbound and outbound clusters, how many client and server clusters does this device have so that you can parse the cluster list. And then there's a special bit mask that each profile can decide to use for indicating either a version of that profile or a set of capabilities. So see your profile implementation for details on that. Now if you use Ember's Insight App Builder tool, the App Builder tool configures the descriptors and the cluster information based on the device type that you choose. So we'll visit that more when we go through the App Builder presentation. So refer to that tutorial for more details. So now you have a basic idea of how the ZigBee architecture is organized up in the application layer, with application profiles sitting on top of the stack, each application profile implemented on an endpoint as a single device type. So each endpoint implements one device from one profile, but you can have multiple endpoints on a single node. And that's how we get standard implementations of different devices running on a node. Thanks for your time. I'm Matt Dibb, and I hope you learned something.